Welcome to 5.5 Double Angle Identities. We will take a look at example 5. Write cosine of 3x in terms of cosine of x. So notice we do not have any triple angle identities. So go ahead and pause and see if you could come up with a strategy to try and write cosine of 3x into a way to be able to use any of these identities. So one strategy is to break up 3x into 2x plus x. So we could write this as cosine of 2x plus x. Notice these are both inside the cosine function, so that's the same as cosine of 3x. Now we could use our couscous formula, or cosine of a plus b. The pattern is cosine, cosine, sine, sine, and our angles are 2x, x, 2x, x, and the plus will become a minus. Notice the directions say to write cosine of 3x in terms of cosine x alone. So we still have to work with the cosine of 2x, the sine of 2x, and even the sine of x. So again, maybe pause, give this a try. But the next step we're going to do is replace the cosine of 2x and the sine of 2x. Sine of 2x is pretty straightforward because there's only one double angle identity for sine. Cosine 2x, on the other hand, there's a lot of options. Let's take a look. If we're only wanting to write this in terms of cosine x, which of these three makes the most sense? It's the one that only has a cosine. So it's this one right here, 2 cosine squared a minus 1. Therefore, I will replace cosine of 2x with 2 cosine squared x minus 1. And I will replace sine of 2x with 2 sine x cosine x. And I'll bring the rest down. I'm leaving those in green. One thing to notice is that this set of parentheses has two terms in it. So I will be distributing this cosine x to the 1 and the 2 cosine squared x. Whereas on the right, this is all one term because there's no adding or subtracting within the parentheses. So this is just going to multiply in once. So multiplying 2 cosine squared x by another cosine x gives me 2 cosine x to the third power, and then minus cosine x. And this one term can be written as 2 sine squared x cosine x. So again, notice this is all one term, so I'm just going sine times sine is sine squared. Again, looking at the directions that I'm trying to write this in terms of cosine x alone. This is okay because this is really cosine x raised to the third power. This one's okay. And then the only problem here is my sine squared x. So think, how could we replace a sine squared x with something to do with cosine? That brings us back to our Pythagorean identity. We have sine squared x plus cosine squared x equals 1. So if we're trying to replace sine squared x, we're going to solve for sine squared x by subtracting cosine squared from both sides. So we have that sine squared x is the same as 1 minus cosine squared x. Notice how much we're using that identity and its different forms. Therefore, I copy everything down except for this sine squared. I will replace with 1 minus cosine squared. Now, I've had a lot of confusion with this last piece right here, so I like to just rewrite it where I put the 2 and the cosine together in the front before I distribute. And it's optional, but I think it will really help make it more clear how it distributes. So again, this step right here, because it's multiplication with a 2 times the parentheses times the cosine x, I can just reorder and make it 2 times cosine x, and then the parentheses at the end. So that's just a reordering, because what that will do is it'll allow me to easily distribute this -2 cosine x to both terms. So we get 2 cosine cubed x minus cosine x, and now when we distribute, we get -2 cosine x, and then we end up with a positive 2 cosine cubed x. Now we combine like terms. So 2 cosine cubed x plus another 2 cosine cubed x gives us 4 cosine cubed x, and -1 cosine x minus 2 cosine x gives us -3 cosine x. Therefore, we have just shown that cosine of 3x is equivalent to 4 cosine x cubed minus 3 cosine x. You might notice that page 4 of the notes in section 5.5 has product to sum and sum to product identities. We are going to go ahead and skip these in this course. You are welcome to look them over and practice them, but I, just for the sake of time and for preparing you for the most important pieces of pre-calc and calculus, I'm choosing to skip those. One thing that is very common is if you are ever expected to use these, you would be given these formulas directly and then using them. So it's not very common to be required to memorize the sum to product and product to sum identities. I hope you enjoyed the video. See you next time.